स्टूडेंट्स, वेलकम टू S2S क्लासेस। आज हम क्या करते हैं कि आपको एक जनरल कंसेप्ट बता रहे हैं जो कि 9th-10th के लिए है। इसमें ज्योमेट्रिकल कंसेप्ट है, ये जनरल कंसेप्ट। क्या कंसेप्ट है कि इफ़ 3 नॉन कोलिनियर पॉइंट्स आर गिवन to find the equidistant point from the 3 non-collinear points. Non-collinear point means which points are not on a straight line. So, okay, now one theorem we know. How can find that point? One theorem is there. What is that? The locus of a point is a perpendicular bisector of the line segment joining the 2 points. It means every point on the perpendicular bisector of line joining the 2 points AB, every point on that perpendicular bisector will be at equidistant from the point A and B both. Yani let us suppose that point, general point anywhere on the perpendicular bisector, anywhere you are taking P. So every point that P that will be at equidistant means PA equal to PB. Always you can take P anywhere on that. It means that if P taking and joining, that will make the isosceles triangle. PAB will be the isosceles triangle. If anywhere isosceles triangle ka vertex C we have to find, then do the perpendicular bisector of this and then equidistant point, that will be isosceles triangle. Anywhere you can take on that. Okay, clear this? Now by this theorem, trace path कहते हैं। लोकस, आई वांट टू एक्सप्लेन द लोकस ऑफ ए पॉइंट का मतलब क्या है? ट्रेस्ड पाथ ऑफ ए मूविंग पॉइंट, ट्रेस्ड पाथ ऑफ ए मूविंग पॉइंट विच इज मूविंग अंडर द वन फिक्स्ड कंडीशन, एज हियर वन फिक्स्ड कंडीशन इक्विडिस्टेंट। तो ऑलवेज दैट पॉइंट इज एट इक्विडिस्टेंट एंड वो मूविंग पॉइंट है। दैट ट्रेस्ड पाथ, उसका क्या बनेगा? ट्रेस्ड पाथ एक लाइन बनेगी। अब वो क्या होगी? परपेंडिकुलर बाइसेक्टर लाइन। उस पर कहीं भी कोई पॉइंट होगा, एवरीवेयर एवरी पॉइंट ऑन दैट परपेंडिकुलर बाइसेक्टर ऑफ द लाइन जॉइनिंग द 2 पॉइंट will be the at equidistance. Okay, so how can draw? With the help of the original construction in the geometry, we are drawing the perpendicular bisector of a line segment. What is that concept? Use that also. What is that? Take compass, original measurement and that compass. So take compass and put the needle of the compass at A and take the more than half AB, means center से थोड़ा ज़्यादा ले लें। Okay, more than half से थोड़ा ज़्यादा, approximate, and then make the arc downward also and upward also. Okay, after that put the needle of the compass at B and take the same distance which once you open, same, and make the arc, and both arc intersect at points. These points you have to join by the scale. That line segment joining these intersecting point of the both arc will be the perpendicular bisector of this AB and produce. Okay, so this is your perpendicular bisector of the AB, and here 90-degree angle will be there, and this point on AB where this line segment will intersect, that will be midpoint of AB, perpendicular bisector of AB. Okay, so this is the line, arrow put both side. We can produce this. Similarly, we can do the perpendicular bisector of BC. Same, open the compass, distance more than half BC, and put the needle of the compass at C and take the distance more than half BC, means वही आधे से थोड़ा ज़्यादा. Okay, and make the arc both side up and down, and after that put the needle of your compass at B and arc where both arc will intersect, that you will join, and that will be perpendicular bisector. Okay, that will be perpendicular bisector of BC, and after that produce this. Then I have made this roughly arc. You have to draw by the compass original, that okay method I explained to you, more than half distance. After that you will join, then this will be the perpendicular bisector line of the BC. A line होंगी, arrow put both sides, then where they intersect, that will be common point. Let this is P, and in this point P will be at equidistance from B, from C, and from A, same distance. So means if we join A to P, join A to P and B to P, similarly C to P with the help of scale, then these all will be equal. AP will be equal to BP will be equal to CP. So this you can measure AP distance by scale and BP distance and CP, all three will be equal. So this is the one construction to get the equidistant point from the three non-collinear point. So this is our required point P, which will be equidistant from the A, B, C, all three. Now one concept more I want to tell you. What is one concept more here? Okay, this point is equidistant means if you want to draw a circle passing through three non-collinear points, then first you have to take this procedure equidistant point P. How can? Similarly you can find perpendicular bisector of AB, perpendicular bisector of BC, and then where will intersect that will be the center point of the required circle. Take the center of the point P and take the distance AP or BP or CP in the compass, and then you can draw the circle that will pass through BAC. Okay, you can check that. Clear that? Okay. Now in isosceles triangle also you know that isosceles triangle property is this, if you draw the perpendicular bisector from any vertex to the opposite side, then this will be the only perpendicular bisector draw, then AB is equal to AC. If on BC from A you want to draw, and that will be midpoint where it will join. Perpendicular, then it will be bisector. If you join midpoint, that will be perpendicular. If you draw perpendicular, then it will intersect to the opposite side at midpoint. So this is the application, this is the use, this is the application used in the isosceles triangle property, and similarly in the equilateral triangle property, that every perpendicular drawn, that will be perpendicular bisector, midpoint also will be there in the isosceles triangle and in equilateral triangle. Okay, correct? Okay, now you can use this construction everywhere in the coordinate system also. This concept used in the coordinate geometry, using, I am telling, in coordinate geometry distance formula you know. So use distance formula if coordinate of A, coordinate of B, coordinate of C given. Find the coordinate of a point P which is equidistant from A, B, C, three known collinear points. Then you can find distance AP by the distance formula, find distance BP by distance formula, find the distance TP by distance formula, and then two equations you can make AP equal to BP equation you can make in the two variable. Yeah, these point P take coordinate A comma B, then in the AB will come one equation. Other equation BP and CP you can make distance formula, other equation, and then solve both equations by substitution method or elimination method, as in third chapter we have solved. Okay, you know that two variable equation we can solve, and then we can find A and B, then that will be the coordinate of the point P. Okay, this is the application, this is the usage of this construction in the coordinate geometry. Okay, in the many other respect also we have to use this concept. So be careful about this concept, it is important concept. Okay, thanks. Now you like, take interest, share, watch and subscribe the channel to get your next notifications. Okay, thank you.